take a look at one more problem that might be considered a little bit tricky. We have an H2O liquid compressible system with a given temperature of 188 degrees centigrade and a given volume of 0.00112 meters cubed per kilogram. Obviously, we're going to find the pressure using our governing equation of the EOS for H2O that is liquid, which we know that is table A7. And we take a look at the values that are available to us. We see that between 180 and 200, which is the isotherm of 188 would lie in this seam. We can see that the values would be bounded here at 5 megapascals by 0.011 and 0.011, with the third digit between 2 and 4 here, third non-zero digit, 2 and 5, excuse me. Move over, it's between 2 and 4. And the red herring here is that this is actually the value that we are given for our specific volume, except of course our volume is supposed to be at 188 degrees centigrade, and this would be at 180. So if we were to interpolate between these two values, we'd get a value that is larger than the value that we seek. So we know that we're definitely not at this megapascal, 10 megapascals. If we go over again, we have 1 and 4 again. So this value could very easily be still larger. This value is going to be larger, and this value could also still easily be larger than our value of 0.00112. Let's head down to the 20 megapascal isobar data. Now we have between 1 and 3, that could still be larger. Between 0 and 3 at 30, still could be larger. And then finally we're between 0 and 1, and that's definitely, between 0.09 and 0.11, that's definitely going to be smaller. So we might have to start our process of interpolating here by kind of a little bit of guesswork. Let's just kind of pick in the middle. Let's pick at 20 megapascals. And let's say, well, we are interested in the value at 188. So we're going to interpolate between 180 and 200 our various volumes, copying and pasting them directly out. And at this value, we can see that we are at a volume of 0.001122, and that is still bigger than what we seek. So let's go down one more and see how this would work at 30 megapascals. If we do that, copy and paste these new values of volume in, we are lower. So we know that we actually have to interpolate between 20 and 30 megapascals. We can't interpolate between 20 and 15. Why? Because both of those values would be larger. In fact, let's just verify that real quick. Interp 1. Actually, let's just use our previous code and put in the values at 15 megapascals for 800, which would be right here, and 200. And we can see that, oh, this value is still larger. So in other words, if I were to make my table, it would look something like this. At a pressure of 15 megapascals, between 180 degrees centigrade and 200, at our interested value of 188, when I interpolate between these two values, I'm going to get 0.001127. And then at my pressure of 20 megapascals, interpolating between the values at 180 and 200, I got the number 0.0011229. still bigger than my desired value of 0.00120. And then finally, when I went all the way to 30 megapascals and interpolated, notice I'm kind of skipping a step here by not writing in the values since I've already copied and pasted them into the code. I got a value that was finally smaller than my desired value, 0.00111. So my value is 0.00112. It is in between these two. And so I can interpolate between 30 and 20, and that would be included in this range. Whereas if I tried to do some kind of mathematical extrapolation between these two values, see this value doesn't lie in between them, so it would be extrapolation, I wouldn't be between nearest neighbors, and so my answer wouldn't be as accurate as it could be and really needs to be if I'm going through the trouble of using the tables in the first place. So here I would do one last interpolation, and just to make it clear, let's copy and paste this into our code. So we had a volume at 20 megapascals that was given to us by this guy, and we had a volume at 30 megapascals that was given to us by this fellow, and then we finally are going to find our pressure by interpolating between those two values of volume. And our value of volume, which we desired, was 0.00112. It's given to us in the problem statement. We save it and we run our file one last time. And we would find that this value of pressure is 23.73 megapascals. And my problem is finished.